Right. Okay, we'll start. Online students, can you confirm whether I'm audible? What about the clarity of the audio and the video? Online students, can you confirm whether I'm audible? Okay. It's fine, right? Okay, thanks. Right, we'll start. Okay, listen. Good afternoon. We'll start. Right. Okay, listen. The first thing is for online students. For online students, if you are already enrolled, you can download the paper from the website. Right? If not, I have pinned a comment in the live chat on YouTube. On YouTube, I have pinned a comment, right, with a link. You can go there to that link and download the paper and get ready. Right? Pages දෙකක් තියෙනවා බලලා ගන්න. මෙතන එකයි මේකයි ඇත්තේ. Page numbers බලලා ගන්න. Right? Okay, so while you are getting ready, listen. I have shared the link of the YouTube live to the group and channel, so you can go there and get it as well. Right, listen, until you are getting ready. Okay, so this is the starting day of paper class for 27, right? So generally there are few things that you should know about writing papers. Since you are writing a paper for the first time, most of you are. Sometimes you might have written the first term test, right? What about you? You don't have. Right. Sometimes you might have written the first term test. If not, most of you haven't written any papers so far, right? So therefore, I'll quickly explain what are the general things that you should know about writing papers, right? Listen, now today we'll be starting off with a MCQ. Today we'll be starting off with the MCQ. And since you haven't written much papers yet, or no any papers at all yet, during the first month, my plan is to write and discuss papers in the class itself, right? In class, writing and discussions. And after second month onwards, my plan is to allocate you separate dates to write papers and dedicate this time only for the discussion, right? So when you write the paper on a dedicated day, if you are writing physical or online, that doesn't matter. It will be collected and graded. And as we are doing in 26 batch, you will be getting the mark with the rank, something like that, right? So my plan is that for your class also, you can get the mark papers, graded papers with the rank. in the next class, once we start writing the papers on a separate day, right? But since I need to make sure that you have the techniques, the practices, common tricks, tips, and everything that you should know about before writing papers during the first month. First month means this month, right? You will be practicing it here with me in the class, right? Otherwise, at once we can't start writing on a separate day because I don't have any idea about where you are, right? There are some things, especially when it comes to structured essays, right? How you should write answers, like to the point answers, concise answers. There are things to know, right? So that's why. So therefore, during these weeks, right? Within the month, I mean, within this month of December, you will be writing papers and discussing the paper itself in the class, right? Then once the other dates are allocated, I'll inform you what are the possible dates to you to write papers, whether you are writing physically. You can write in both institutes, here in Leesa or Meshma, wherever it's possible, wherever it's preferred to you. And if you are writing online, for online ones also, you will get a allocated day or maybe 2 or 3 days. During those days, you can write and submit, right? Okay. Now I hope all of you have downloaded the papers. Right. Now today, this is going to go like this, isn't it? This is going to go like this. We'll be starting writing an MCQ paper, right? And we will start writing the MCQ as sets of 5 questions, right? Because today you are going to write 25 MCQs, right? A MCQ paper of 25 MCQs. We will be writing as sets of 5, which means for first 5 questions, I'll be giving you a time, right, to try, and then going to discuss first 5. And then for the second 5 questions, again, I'll be giving you a time for you to try, and then going to start the discussion. So likewise, we are going to complete 25 MCQs by the end of the class, right? And next week, you are going to write a part 2, which means structured essays and essays, right? So likewise, first I'll make sure that you are on track about writing each type of questions, because the way we are writing an MCQ is totally different from the way we are writing an essay for a structured essay, right? So likewise, basically we have 3 question types now: MCQs, structured essays, and essays, right? For each type, there are different ways, different approaches that we should know, right? They are different from each other, different from one another, right? That's why. So today, we will be starting the first MCQ, right? Paper 1, part 1 actually. Paper 1, part 1. So next day you will be getting paper 1, part 2. Paper 1, part 1. Right. So here this consists of 25 MCQs, right? So you might have already downloaded and you have seen the paper. Don't look at the questions yet, right? Just be honest with yourself and wait. Online මොනා කරනවද කියලා වෙන්නෙත් නැහැ. ලියන්න එපා. Right? 25 MCQs now. We will be writing as sets of 5 questions. Sets of 5. Right? First, I'll be giving you a time for first 5, and you have to write first 5 questions, answer first 5 questions during that time. Since they are MCQs, right? If there are questions that you don't know any answer at all, right? Don't keep it blank, right? You can choose one answer before the discussion, right? Blank they are MCQs, no? Right? Anyway, we'll be discussing. Since they are MCQs, don't keep blanks, right? Now, if there is 5 questions, mark 5 answers for 5 questions before the discussion, right? දන්නේවත් තියෙ නැතිවත් තියෙ. හැබැයි theories වලින් දන්නේ නැති කිසිම එකක් මේකේ තියෙන්න විදියක් නැහැ, right? right? Okay. And when you are writing answers, when you are trying questions, you can be honest with yourself and close your books and try, right? Open book exam එකක් වගේ open book වගේ කරන්න එපා. ඒකට වැඩක් නැහැ නේ. Right? Close book එකක් කියන්නේ ඒ විදිහට try කරන්න. හරිනේ? So we will start. I hope everything is clear and okay. Any questions before starting? All good? Online? Any questions before starting? Anything to clarify? Anything to clarify? Put a thumbs up at least if there is. Fine. Okay. All right. Okay. Then we'll start first five. We'll start first five. There is 6:42 now. I'll give you 10 minutes for first five questions. Start now for first five questions. 1 to 5. Start now. 1 to 5. 1 to 5. And 6:42 to until 6:52. Start now. So I didn't get the paper. You are enrolled on the website, right? In the same week, you can see the PDF, right? When you go to the week, you can see the PDF just below the class joining button. Okay, try first five questions. If you notice any typing errors or something like that, kindly let me know. If I didn't notice any typing errors, if you notice something, just tell me. So now we have dimness yours. Ashwi, I hope you have downloaded the paper. Start first 5 questions. Start first 5 questions. If you have finished already, you can check again. Okay. Finished? Time is enough, right? Okay. Let's go to the discussion now. Listen, listen. Right. So before jumping into the discussion, since there are some new students in the online class, uh, yeah, this is how you should enroll. Right? If you are joining the class, listen. all online enrollments are done through the website. You can visit this. You can visit this and create the account. Create the account, and once the account is created, you can go to the respective class, and where an enrollment key will be asked. As the enrollment key, use this. Both P's are capital. Use this as the enrollment key, right? So join into the class, accessing recordings, getting the paper, right? So once graded papers are going to be started, grades and everything will be getting through the website only, right? So therefore, this is how you should complete your enrollment. If you are riding physically, if you are coming to the physical class, no need to create this account. You can just come to the institute and register to the class, right? This is only for the online students. And for the physical ones also, if you need a recording, right, you have to get the recording through this. So therefore, it's better if you can also create the account and keep it there, because if you need the recording, you can access the recording here, right? For online ones, it's mandatory, because joining and everything, all the things with respect to the class will be managed through the website, right? Everything. So therefore, that is how you should enroll, right? Okay. Let's see. First one. Which of the following is not an SI fundamental unit? Right. Very straightforward. Very straightforward theory question. So before fundamental units, tell me what are the fundamental. I'm just recalling the background. So with the question, I'm recalling the background. If you can't remember these things, right? So you better take down a note. You better take down the note, right? Even though if you have that in your books, if you can't recall, right? Once you have the question, which means you haven't gone through, and that is not in your head, right? So therefore, you can make your own note with the discussion, right? Sometimes I'll be giving some points as for you to write down, but even if I'm not giving it as a point, if you feel like you are lacking that part and you need it, right? You can make your own note. You can take it down, right? Something like that, because this is not like a theory class. In theory class, now I'm giving you the note and then only you are writing down, right? This is a paper discussion. So therefore, the conduct of the class is different from a theory class, right? Sometimes I'll be giving the special points, important points, generally. But if you feel like, particularly if you feel like you don't know that part, or that is not in your head, what you can do is you can take it down. And it's better if you can either keep a separate book for paper discussions, or if you are writing discussions in sheets, you can attach the sheets to the paper and keep it in a folder or something, because now we are starting with paper 1, and by the time you are sitting for the exam, I don't know, around 50-60 papers we'll be writing. You have to have all papers with you to refer at any point of this A-level journey. So therefore, keep it in a folder. That is better, right? තැන තැන දාන්න එපා හොඳද අද පේපර් එකේ ඊට පස්සේ හෙට බලද්දි අත පිහි දාන්න අරගෙන හරි ඔකේ කරාට පස්සේ ඉතින් ඉවරයි. So therefore, that is up to you. Keep this with you in an organized way, right? The purpose is you should be able to refer these papers again and again at any point that you need to refer, right? Okay, first one. First, tell me, what are the fundamental physical quantities we have? Question 1. What are the fundamental physical quantities we have? How many fundamental physical quantities? 7. Yeah, name them. Online ones also. You should respond. First one, mass, length. Very straightforward. Length, time, amount of substance. Amount of substance. What else? Huh? Thermodynamic temperature. Right? Heat name. Thermodynamic temperature. thermodynamic temperature. This word is a must, right? Otherwise, relative temperatures are measured in degrees Celsius. That is a different thing. What else? Luminous intensity. Last one. Online. Yeah, I'll come to units. Right, first tell me the physical quantities. What did you miss? Electric current. Electric current. Electric current. Okay. And you should know the SI units of each of these physical quantities. Mass. What is the SI unit of mass? Kilograms, right? Not grams, kilograms. Length, meters. Time, seconds. Amount of substance, moles. Thermodynamic temperature, kelvins. Electric current, amperes. Luminous intensity, candela. Candelas, CD. Simple C, simple D, candelas. Right? Okay, now the question is, now this is a background theory part. This is a background theory part with question 1. Right? Something we are doing, we are covering on the very first day that we are starting the class. Starting the theory class. First day lesson. Right. Which of the following is not a SI unit? Man, you should have told me now. The mistake is this. This should be a simple K, capital K. So in the first question, the given one should be a simple K. Simple K should be the answer. Please make that correction. I didn't notice it. Right? Correct. Answer 4 as a simple K. It should be a simple K. It should be a simple K. Right? Simple K is strong because the temperature is, the notation is capital K, kelvins, capital K. Right? Right? It should be simple K. Make that correction. Right? Please make that correction. Then for first one, answer 4. For first one, answer 4. This is a simple K, right? Not a capital K. It should be a simple K. Make that correction. It should be a simple K. Should be a simple K. Right. Second one. Typos මොනවාරි දැක්කොත් කියන්න. ඒ කියන්නේ answer එකක් නැත්නම් හරි typo එකක් හරි මොකක් හරි. If you notice something, just tell me. Second one. The figure shows the variation of a quantity x with time t for a projectile. The quantity x would be, right, something very straightforward. So we know there are basically two velocity components in a projectile motion. Right? What is a projectile motion? What is a projectile motion, by the way? What is a projectile motion? Under gravity, no. Then what about this? Also under gravity, no? What is a projectile motion? Quickly. Online? What is a projectile motion? There should be a keyword there if you are defining a projectile motion, if you are introducing a projectile motion. Parabolic path, parabolic trajectory, right? If an object travels in a motion acting in two directions, no, right? That's not the definition. By definition, projectile motion is a motion of an object along a parabolic path. Parabolic path, that's a keyword. Along a parabolic path. Parabolic. Parabolic. So this is called a parabola. This path is called a parabolic path. Right? Such motion is a projectile motion. Such motion is a projectile motion. Right. Now, from the given graph, you can see this quantity x is constant over time. right? There is a constant over time. There is a constant over time, right? The quantity x would be, okay, something very straightforward. We know, see, we know at any point of the motion, the velocity can be represented by two vectors, no? Say v1, v2. Velocity can be represented by two vectors in a projectile motion because the actual direction of velocity is in between. That is along the parabola. That is along the parabolic direction. So therefore, basically we are splitting this into two components, one horizontal component and a vertical component, right? This vertical component changes over time because acceleration g due to gravity acts vertically downward throughout the motion, right? It acts vertically downward throughout the motion. So therefore, this v1 is impacted by this g, no? This v1 is impacted. So therefore, this v1 varies with time. So therefore, this v1 varies. v1 varies. But v2 is horizontal. v2 is horizontal. Whereas acceleration due to gravity is vertical. These two are two perpendicular directions. This perpendicular vector, perpendicular acceleration cannot impact on the horizontal velocity. Therefore, there is no acceleration acts on the object in the horizontal direction. There is no acceleration acts on the object along the horizontal direction. Therefore, the impact of this is v2 remains constant. v2 remains constant, right? That is something we have proved in projectile motion, right? Something we have proved in projectile motion. So in red, you have written this in your note, right? So therefore, it should be a horizontal component of velocity, right? We can't say velocity because velocity changes. Velocity changes from point to point. Only the horizontal component of velocity remains unchanged. Since v1 changes, the resultant changes. Since v1 changes, resultant changes. Horizontal component of velocity 4. For 2, answer 4. Right? Something you already knew. Next, question 3. If any questions about the questions we are discussing here, you can raise whether you are online or physical or whatever it is. 3. Which of the following graphs does not correspond to an object moving with a positive acceleration? Right. To a positive acceleration. Okay. One thing is very straightforward. We know gradient of Vt is what? Gradient of Vt gives acceleration. Gradient of Vt graph gives acceleration. Right? Gradient of Vt graph gives acceleration. So if that's a positive acceleration, it should be a positive gradient, no? That's the idea, no? Gradient of M means gradient. Vt equals acceleration. Right? If this given acceleration is positive, right? This gradient should also be positive. Gradient should be positive, right? From Vt graphs with a positive acceleration, right? This is given. Isn't this a constant positive acceleration? That is a constant positive acceleration, right? And few ST graphs are also given. Tell me, what is represented by gradient of ST? Velocity, right? Gradient of ST, this is the theory part involved here, is velocity. Now, if there is a positive acceleration is rate of change of velocity. There is an acceleration, velocity should increase over time, right? If there is accelerating, velocity, magnitude of velocity should increase over time, right? If that increases over time, velocity is given by the gradient, no? If velocity increases, make the idea. If there is an acceleration, right? If there is an acceleration, it should be an increase of velocity. If there is an increase of velocity, right, it is represented by the graph as an increase of gradient. It should be represented by the graph as an increase of gradient, right? Then in the SC, a positive acceleration is given with an increasing gradient. Is it clear? Acceleration velocity increases over time. When velocity increases, gradient of this graph increases. Velocity is represented by the gradient, no? Increasing gradient. Increasing gradient in graph. This is an increasing gradient, right? So you know gradient types. This gradient type is called a positively increasing gradient. So there is a positive acceleration. There is a positively increasing gradient. We have discussed all gradient types with signs and everything under linear motion graphs, right? That's the respective theory part. So both of them are correct. D and C. This says, wait, this says an object moving with positive acceleration. What about D? What about D? What about graph D? How many were now? Now, acceleration of the gradient of Vt changes over time. This is an increasing gradient, no? This is an increasing gradient. And it changes over time. Make a positively increasing gradient. If there is a positively increasing gradient, this represents a positively increasing acceleration, isn't it? It's a positively increasing acceleration, right? So therefore, this is also acceptable. Make a right? Maybe change in acceleration. There is not a constant acceleration, there is a changing acceleration. Possible? Changing acceleration. It should be BCD. Does not. Does not. Only A. Right? Only A. Does not correspond to. Now, these three are correct. These three are correct. Make a ain't back. Then go to cloud A and D. You know the answer. I can have it. Right? All three are correct. So therefore, only A is wrong. Only A is wrong. A will the that's a uniform velocity. A is a uniform velocity. Acceleration of A is 0. If there is a uniform velocity, make an A graph. This is a graph A, ST, with this, right? So these are positive constant gradient, which means this is a positive constant velocity. If there is a constant velocity, acceleration is 0. If there is a positive constant velocity, acceleration is 0. No acceleration. No acceleration. So only A is wrong. Only A means 1. For 3, answer 1. Right? So that's a good question. Right? Linear motion graphs. Linear motion graphs. We have discussed everything in the theories about gradients, signs, gradient types, parameters, everything. Okay, is it clear? This is also correct. This is an increasing acceleration, right? This gradient is rate of change of acceleration, right? Note gradient of Vt graph is, right? Sorry, gradient of Vt AT Vt gradient of AT from AT graphs and gradients. Usually you don't get questions, but yet I have mentioned that in the note as gradient of AT is rate of change of acceleration, right? Okay. Make a constant acceleration. The difference between these two is confused. Difference between these two is this represents a constant acceleration, whereas this one represents an increasing acceleration. That's the difference, right? Both are positive accelerations, right? Okay, 4. Okay, is it clear before moving on? Clear, right? More than make that. Are pick කරාද? ඒ කියන්නේ මේක හරියට ගත්තා. හරි. හරි clear? Online, is it clear? Yes. Okay, good. 4. Which of the following measurements were not taken using a meter ruler, vernier caliper, or micrometer screw gauge? Right. This is a popular question type. Listen, this is a popular question type. The needed theory part, required theory part for the question is, you should know least counts of each measuring instruments and maximum readings. So that's my point. Right? Quickly, what are the instruments we have? Make the theory part. This is the theory part. This is what you should know. Right? Instrument, least count, maximum reading. Right? First one, meter ruler. Meter ruler. What's the least count of meter ruler? 1 millimeter. 1 millimeter. Least count of meter ruler, 1 millimeter. 1 centimeter is divided into 10 small divisions. No? Right? 1 millimeter. Maximum reading of a meter ruler? Not 1 meter. There's no maximum reading. 2 meters can not put on. Right? Make it nah. There's no end from the maximum side. Right? Second one. Vernier caliper. Vernier caliper. What's the least count? 0.1 millimeters. 0.1 millimeters. Maximum reading? 15 centimeters. Alright? 15 centimeters. 15 to 20 by default 15. Next one. Micrometer screw gauge. Micrometer screw gauge. Please count. 0.01 millimeters. Maximum reading? Maximum reading? Online? Maximum reading of a micrometer screw gauge. Theory part maximum reading of a micrometer screw gauge. What is the maximum reading of a micrometer screw gauge? Very straightforward. 25 millimeters. Micrometer screw gauge. 25 millimeters. 25 millimeters. Sperometer. Please count. Same. 0.01. Maximum reading? 10 millimeters each side. 10 millimeters each side. Right? Last one. Traveling microscope. Traveling microscope. Please count is same. 0.01 millimeters. Maximum reading is also same as this 15 centimeters. 10 maximum 50. Right. This is the respective theory part. This is the respective theory part you should know. Okay. Now, let's see. Now all values are given in centimeters. Since that is given in centimeters, I'll convert them to millimeters first because we are more familiar with millimeter readings. Least counts are usually referred in millimeters and some of the maximum readings are also referred in millimeters, right? So therefore, I'll convert these given readings to millimeters first. Only 4, A, B, C, D. Right, A, 10.5 centimeters means 105 millimeters, no? Right? Second one, 22.35 millimeters. C, 106.67 millimeters. D, 205.7 millimeters. 205.7 millimeters. Right? Sperometer. Four is sperometer. Meter ruler, vernier caliper, micrometer screw gauge, sperometer, traveling microscope. Right. Now go to first reading. 105 millimeters. 105 millimeters. Are there any decimal millimeters here in this reading? No. Decimal millimeters, then always a reading can be taken to the equal number of same number of decimals in the least count only, right? So if there are no decimals in this reading, which means least count of this instrument should be 1 millimeter. Point at the because always a reading can be taken to the same number of equal number of decimal points that is there with the least count, right? So if there are no decimals, there shouldn't be decimals in the least count. If there is only one decimal point, there should be one decimal point in the least count, right? 105 millimeters. Meter ruler again, 1 millimeter, right? Meter ruler is capable of measuring anything more than 100 as well, right? Make a meter ruler again, meter ruler, right? Second one, 22.35, 22.35 millimeters. How many decimal millimeters? 2. What are the possible instruments? Micrometer, screw gauge, spirometer. Now spirometer is out of the list, right? Make a list again. Not taken using a meter ruler, vernier caliper, micrometer, screw gauge. Both spirometer and traveling microscope is out of the given list, right? I mentioned all the instruments we have, right, at once when I'm recalling. But for the question, only meter ruler, vernier caliper, and micrometer, screw gauge is relevant, right? Now, 22.35. 2 decimal millimeters. Micrometer, screw gauge is possible, and maximum reading is 25. This is below 25, which means possible, right? For this, micrometer, screw gauge. Micrometer, screw gauge. Right? Hold on. Next one. 2 decimal millimeters. 2 decimal millimeters. From the given list, the only possible instrument to get 2 decimals is micrometer, screw gauge. But maximum reading of a micrometer, screw gauge is 25 millimeters. This is more than 25. So this cannot be taken. This cannot be taken. Right? 205.7 millimeters. 205.7 millimeters. How many decimal millimeters? 1. Answers dekak tiyan puluhan. 1 decimal millimeter. Then only instrument we have having 1 decimal millimeter is vernier caliper. But maximum reading is 15 centimeters. No? This is something more than 15. Right? Something more than 15 cannot be taken. Right? Which of the following measurements were not taken using? Were not taken C and D. Right? C and D again. 3. For 4, answer 3. So that is how you should use these logics. Right? The underlying theory part is this. Underlying theory part is this. Take this down if you don't know these values. I mean, there's no point that you don't know if you are in the theory class. Right? Make a summary ekkuth mama antimata dila idi. Summary table එක. දුන්නානේ? අපේ summary table එකකුත් දීලා ඉතින්. Last one. 5. This is clear, right? The popular type pair, right? This is a popular question type when it comes to measuring instruments MCQs, right? මේ ඔක්කොම දන්නේ නැත්නම් කරන්න බෑ, right? Any instrument out of these 5 can be given, right? Question 5. Question 5. A bird is flying horizontally at an altitude of 180 meters. A bird is flying at an altitude of 180 meters. This one. This is 180 meters from ground. 180 meters from ground. Right? When the bird is directly above him, a boy throws a stone at 120 meters per second, making an angle of 30. Right. So at this point, say this is t equals 0, and this is t equals 0 of the boy, right? And that boy throws this with an angle 30. At the same point, when time equals 0, bird is exactly on top of the boy, right? directly above him. A boy throws a stone at 120. 120, m is minus 1, making an angle 30. If the stone hits a bird, the speed of the bird should be, if the stone hits a bird, right? If this stone hits a bird, tell me which parameter in terms of this projectile motion. Now, this is going to be a projectile motion, right? Projected with an angle, that is a projectile motion. Which parameter of this projectile motion is going to be equal? If they are hitting means that is also meeting. Hitting, colliding is a meeting. What should be equal in order to hit, in order to meet? Vertical velocity, no. Meetings logic online displacement, good, right? Displacement, vertical displacement, right? So even though the velocities are equal, if they are physically at two different points on the space, they are not going to collide, right? So if they are colliding is a meeting. Colliding is a meeting, right? If two objects are meeting, they should be physically at the same point. Displacements are equal, right? Displacements are equal. Then, if this projection goes like this, and if this bird travels like this, somewhere here, we don't know at which point, this is not a special point, not the maximum point, we don't know, right? At somewhere here, they will meet, right? This travels in the projection, the bird travels in a linear motion, right? What about the time? Equal or different? Times are also equal because they started the motion at t equals 0 and until the meeting point, same time goes. So let's say t equals t. So they are meeting here at t equals t, right? Then apply two equations considering these two motions. What is asked? The speed of the bird. Okay. And one more thing, what can you say about horizontal displacement? Is it equal or different in this scenario? Once you have the diagram only, you will see these things. Otherwise, don't try to imagine this. I mean, it is too difficult to imagine. Have the diagram, right? Extract this data from the question and know the diagram. Then only you will see. Right? Once something is visible, once the diagram is there, that visibility is higher. Otherwise, you have to imagine all the things in your head. What about horizontal displacements? Equal or different? That is also equal. That is a special scenario. Horizontal displacements are also equal. Say horizontal displacement from here to here is r and vertical displacement is 180. You know, they are equal. Right? Okay. Now, apply few equations. You have a projection and a linear motion. Right? First, we will consider the projection. Projection consider considering the projectile motion horizontally, we can use S equals ut, right? Which means R equals U is 120 cos 30 into T, 120 cos 30 into T, right? So first equation is here, first equation, cos 30 is root 3 over 2, then this is 60 root 3 T equation 1, right? Then you can apply another equation vertically upwards for the projection. Still with the projection, no? Is equals ud plus half AD squared, right? S is 180. This for stone, no? This also for stone. S stone. This also for stone. Right? 180. What about you? 120 sine 30. Right? My components are towards the angle cos component 120 cos 30. Away from the angle sine component 120 sine 30. Right? So here 120 sine 30 comes. Right? T plus half, we are using the equation upwards, but direction of gravitational acceleration is downwards, right? Half, this is minus 10, minus g, minus 10 t squared. Right. See what's happening? Only unknown variable is now time, which means time is determinable just by using this equation. Right? Time simplify this. 180 equals sine 30 is half. Then 120 into half is 60. 60t. This is 2 and minus 10 5 minus 5t squared. Right? This is divisible by 5. This is divisible with 5. Right? 5 and divide current. 5 times 12, 36. Right? 36 equals 12t minus t squared. Take this to the other side. Final equation, t squared minus 12t plus 36 equals 0. T squared minus 12t plus 36 equals 0. Right? Factorize this. What are the factors? 12 and 36. 12 and 36. One thing. 6 times 6. Oh, 6 times 6. Minus 12 and plus 36. Again, minus 6 and minus 6. You can make a perfect root. This is the perfect square of t minus 6. T minus 6. Whole thing is squared. Perfect. So only answer for t is t equals 6 seconds. T equals 6 seconds. Right. Now t is known. If t is known, we know r. T is known, which means r is known. Horizontal displacements are also equal. Now, going to use an equation for bird. D for bird. Horizontally, S equals ut for bird. Same displacement r. U is what we need now. Speed of bird, right? This is a good question. No? Good combination of linear and projectile motion. T is 6. Right? For r, you can plug from here. From 1. R is 60 root 3 equals sorry? T is 6. T cancel or T actually cancels. These two cancels. U equals 60 root 3. U equals 60 root 3. Right? Answer 4. Question 5, answer 4. Now, if we saw that t is going to cancel at first, make a try right? Right? So if we saw that as t is going to cancel, if you foresee this step as t is going to cancel, without trying this, right? Without doing this simplification, at once you can apply this and see. Right? Okay. 60 root 3. That's a good combination. That's a good combination of linear motion and projectile motion. Good combination of linear motion and projectile motion. Okay, any questions? Outcome. Time. Yeah, times are also equal. Now here more things. Time, horizontal displacement, vertical displacement. Everything are equal and meeting each other. Meeting a requirement again. Requirement for a meeting is displacement. Right? Because even if times are different also, two objects can meet. Right? If they started in two different times. Vertical displacement. Vertical displacement is equal. Horizontal displacement. Vertical velocities are equal because why? Horizontal displacements are equal. Velocity is equal. මෙතනින් තමයි ඔයගේ ආගියුමන්ට් එක එහෙනම් බිල්ඩ් අප් කරන්න ඕනේ. හරිනේ? මුලින් මේක චෙක් කරගන්න. Whether displacements are equal, because if horizontal displacements were different, velocities are going to be different. Right? Then same time එක start කරලා horizontal velocities, horizontal මේ displacements to equal හින්දා අනිවාර්යෙන් velocity එක same වෙන්න ඕනේ. මේ කියන්න පුළුවන්. මේ කියන්න පුළුවන්. Not a general fact. For the specific question, that is correct. Any other questions? Online? All good? Online? Any other questions about this? Any other questions about this? Okay, right. Let's go to next 5. You got it? Take it down, and start next 5 questions. 7:33. Try questions 6 to 10. We'll give you 10 minutes again from 7:33 to 7:43. Start now. Start next 10 questions. Sorry, next 5 questions. Start next 5. So the horizontal velocity remains same. Yeah. You're asking about the bird, right? About bird. Rashri. Both objects. For a projection, we don't have to think anything because anyway horizontal component of a projectile motion is same. Right? Now for the bird, since there is no mentioning about the acceleration, it is also constant. Try next 5. Okay. Right. Question 6. Question 6. Okay. Let's see. Displacement x of a particle executing simple harmonic motion is given by x equals a sine omega t plus phi. X equals a sine omega t plus phi, where t is time and a and omega constants. The dimension of the product a omega is. Right. So we know we have 5 dimensionless occasions. Right? We have 5 dimensionless occasions. That's the theory here. What are the dimensionless occasions? Theory. The respective theory part is this. What are the dimensionless occasions? There are 5. First one is numbers. Second one, logarithms. What else? No, dimensionless occasions. Angles, trigonometric ratios. Last one, indices. Right? These are the dimensionless occasions. There are 5 dimensionless occasions. Right? These are the dimensionless occasions. There are 5. Right? Now, see, this one is an angle. This is an angle. So this angle is dimensionless. Sine, inside sine, it should be the angle. That is dimensionless. If there is dimensionless, these added 2 terms should also be dimensionless. Right? Dimensionless term can be added with another dimensionless term only. Then only the addition is going to be dimensionless. Addition, right? Then only the addition is going to be dimensionless. Therefore, my first argument is product omega t. Dimension of product omega t should be dimensionless. That is 1. Dimensionless scale again 1, right? Then find omega. Omega, dimensions of omega times dimensions of t is capital T equals 1. So this is here. Dimensions of omega is t minus 1. 1 is here. Dimensions of omega is t minus 1. Right? Then you need dimensions of a. The part from here is a trigonometric ratio. There is a trigonometric ratio. That is also dimensionless. Whole sine term is dimensionless. We know an equation should be dimensionally equal in left hand side and right hand side. Now left hand side is only x and right hand side, this whole thing is dimensionless, only a remains. Right? So therefore, dimension of LHS of an equation equals dimension of RHS of an equation. From LHS, dimensions of x equals RHS. This whole part is dimensionless, so only a remains. X is a displacement. It is given, no? It is given, no? Displacement x. Right? So therefore, dimensions of A is dimensions of displacement L. Right? You need the product A omega. Dimensions of A omega is, right? A is L. Omega is t minus 1. So this is LT minus 1. 5. So 6. Answer 5. Right? Take it down and ask if any questions. Indices. Okay, good. I need one more favor from you. There were few requests came from especially from online students whether there is a possibility to start this class at 7, from 7 to 10. So what's your opinion on that? If we shift the class by another 30 minutes, if we do the class from 7 to 10, this class from 7 to 10 would be fine, or I need the response of the majority. I mean, I'm going to see the vote of majority and do something, right? So therefore, please vote and respond. If that happens, what about you? Okay, it seems fine, right? Yeah, it seems fine. So if it's fine, we can shift it to 7, right? If it is fine, we can shift it to 7, then it will be from 7 to 10, right? Right. 7. Question 7. Figure A shows the scale reading when the spindle touches the anvil. Figure B shows the reading when measuring the diameter of a cable using a micrometer screw gauge. The diameter of cable is. Right. First tell me, is it a negative 0 error or a positive 0 error? Negative or positive? In figure A, we have a 0 error. Positive or negative? Negative. That's a negative 0 error. If 0 is above the center line in a micrometer screw gauge, if 0 is above the center line, there is a negative 0 error. If 0 is below the center line, there is a positive 0 error. Now in this case, there is a negative 0 error, right? So first we can find out the negative 0 error. Negative 0 error is total minus coincided divisions, right? Total minus coincided 50 minus coincided 47 times least count, right? You should know the least count. Micrometer screw gauge, the typical one of 50 parts, then 0.01 millimeters. Then simplify this, 3 times this 0.03 millimeters. This is the negative 0 error this instrument has. Right? Now take the reading. Now you can take the reading. We know reading equals reading of main scale plus reading of vernier scale of the instrument. Reading of main scale is completed main scale. Completed main scale. In a vernier, in a micrometer screw gauge, gap between two divisions at same side is 1 millimeter, and gap between two divisions at opposite sides like this is 0.5 millimeters, right? Okay, then main scale is 0, 1, 2. 2 are completed, no? 2 millimeters. plus vernier scale is read as number of coincided divisions into least count. Number of coincided divisions into least count. Number of coincided divisions. Count from the bottom. 30, 31, 32. Coinciding is taken, considered with the center line. Na? With the center line. 30, 31, 32. 32 divisions are coincided into least count 0.01 millimeters. Right? This is 2 millimeters plus 0.32 millimeters. Apparent reading is 2.32 millimeters. Right? Now this should be corrected. This should be corrected because it has an error. It has an error. So it should be corrected. Right? Should be corrected. That was a negative error. For a negative error, which correction should be done? A positive correction. Right? A positive correction. So the corrected reading is apparent reading plus negative 0 error. Right? 2.32 plus 0.03. 2.35 millimeters. 2.35 answer 2 for 7 2. Measuring instruments, micrometer, screw gauge. 8. A particle is projected vertically upwards with velocity 40 ms minus 1 from the top of a tower. It hits the ground after 10 seconds. The height of the tower is, right? And if the tower is like this on ground, right? Once this object is projected upwards from this point, from the top of the tower with 40 ms minus 1, right? The afterward motion it goes up and then only it comes down. Something like this, right? Projected vertically upwards from the tower. From the tower vertically upwards. From the tower vertically upwards. Right? And height of the tower after 10 seconds. Okay. This whole motion takes 10 seconds. Right? From A to B at once, from A to B downwards, we can use S equals UD plus half AD squared. Right? This is a linear motion. S is H, height of the tower. U, I'm going to use the equation downwards, but U is upwards, minus 40. T is 10. Right? Using the equation downwards, G is also downwards. So this is plus half 10 T squared. T squared is 100. Right? 10 squared, 100. Which equals minus 400. This is plus 500. So H is 100 meters. 100 meters, 2 again. It is an easy one if you understood the question properly. इधर आंसर करते हैं ना, इधर आंसर क्या? 500. Right, write down. Question 9. Displacement time and acceleration time curves for an object projected vertically upwards are, right? For an object projected vertically upwards, like this, right? So we know the afterward motion is it goes up to a maximum point and it comes down, right? It is coming to the same point, which means displacement should be 0 at the end, right? And this whole motion is under gravity. This whole motion is under gravity, right? So first point you should look at is acceleration. That is easier, right? Check acceleration first. Okay. What about the acceleration throughout the motion? Is it a constant or a variable? Acceleration is a constant. Acceleration is a constant. Acceleration is a constant. And for the upward motion, there is a downward acceleration. Downward acceleration. So therefore, acceleration is constant and it's negative. Right? We are considering an upward motion. With respect to that upward motion, acceleration is downwards. That is negative. Right? Negative accelerations එකයි 4 and 5 no? About displacement. About displacement, you know, right? It is going up to the maximum point and it should come back. Then final displacement should be 0. Final displacement is 0 again. Because it is coming back to the same point after completing the motion. Right? Final displacement is 0. So therefore, displacement time graph is something starts and ends at the same point. 0. Displacement should be 0. Right? Answer 4. For 9, 4. Right? Check the behavior. Check the behavior. Increasing the displacement up to a maximum point and decreasing and coming to 0. For displacement, why are we considering both? Both means? What do you mean by both? For displacement, why are we considering both? Vertical motion and horizontal motion. No. This is only a vertical motion. This is a vertical motion, it is given. Displacement time and acceleration time curves for an object projected vertically upwards. That is only a vertical motion. Right? So it is vertically going upwards and coming downwards. Right? So this is the vertical displacement. Increasing, reaching the maximum point and decreasing over time. Right? 10. When the thickness of a thin sheet is measured, it reaches 1.20 millimeters. Thin sheet. When the stack of 3 such sheets is measured, the thickness reaches 3.80 millimeters. The zero error of the instrument is right. First idea is zero error is given for a given instrument, which means zero error is a constant value, a given value for the same instrument, right? Whatever the reading you are taking out from the instrument, right? Zero error is same. Zero error is same. Reading. Zero error is not going to change by reading to reading. That is same for the same instrument, right? Then we don't know the actual, what we call thickness. We don't know the actual thickness of a sheet now, right? So let's consider actual thickness of a sheet as T, right? Then in the first case, this reading should be actual thickness plus this error. No? We don't know whether it's positive or negative. If that is negative, you will be getting it as a negative value. So therefore, don't worry. It should be the addition or subtraction with the zero error. Right? Plus scale. If there is negative, you will get it as negative. This is the first one. First reading is given 1.20. Then 1.20 equals that actual thickness plus this. And second scenario, 3 such sheets. Then 3.80 equals, second reading, 3.80 equals, see, 3 sheets, no? 3D. 3D. Huh? Yeah. Stack means like this. Huh? These 3 sheets are kept like this on each other. Stack of 3. This is called the stack of 3. Right? We made it 2, stack of 3. Something like this. Then the actual thickness is 3D. But yet, the error is E. Mona reading anything. Error is same. Error is same as E. Right? What you can do? Now we need to cancel T. two simultaneous equations. You have to cancel t now. Multiply first equation by 3 and subtract. Multiply the first one by 3 and subtract. See? 1 times 3. And then you physics, this is simplification. Right? Or what? 1 times 3 is 1.2 and 3.60 equals 3d plus 3e. Say 1 dash, right? Subtract 2 minus 1 dash. 3.80 minus 3.60 is 0.20. Right? 3d cancels. 3e minus e, 2e. 0.20 equals 2e equals 0.10 millimeters. 0.10 millimeters. Is it positive or negative now? It's a positive value. It's a positive value. Right? Negative value. It's a positive value, which means the error is positive. Error is a positive reading. Positive error is a positive value. So which means is a positive error plus error, positive error. Then the correction should be negative. Correction should be negative. Then value is 0.1, 0.1, and negative correction, no? Negative correction is a subtraction. Negative correction is a subtraction. 0.1 and it should be subtracted. 2. For 10, answer 2. For 10, answer 2. This is a good question from the measuring instruments and errors. No, not the traditional type. Not the traditional type. This is a good one. And this question has not yet come in past papers as well. Okay. New question. Right? This is not yet come. This has not yet come in past papers. Get the concept. Get the idea. Understand the concept. Mention this point in red with a question. Mention this point in red with a question. Zero error of an instrument. 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 Zero error of an instrument is constant for the instrument, right? If you are using the same instrument, zero error is same. That is irrespective of the reading, right? Zero error is irrespective of the reading. Right. Start next 5. 11 to 15. 8, 6 now. Right? 11 to 15. Right? I'll be giving you 10 minutes again. 8, 6 to 8, 16. Start now. This should not be E minus 3. 2 minus 1 dash, no? Into, sorry. It's correct. Oh, wait. Make it change that. It is E minus 3, right? 2 minus 1 dash. E minus 3. Yeah, thanks for raising it. Yeah, it is correct. Sorry about that. E minus 3. E minus 3. Then this is minus 2E. This is minus. So there is a negative error. Okay? There is a negative error. So answer changes. Since there is a negative error, it should be a positive correction. Right? 0.1 millimeters and it should be added 1. Yeah, thanks. Be vigilant. Mistake. All right. Start next 5. Next 5. Actually, question 13. In question 13 about inertia, you don't know yet, right? Inertia then you don't know yet. Take a mistake question. Inertia is coming up in rotational motion, right? The next lesson, rotational motion. Inertia is coming up in rotational motion, right? Skip question 13. That is fine. I will give you the answer, but since you don't know yet about inertia. $15. Okay. It should be given as vector AB. There's a vector. There's a vector as AB. Right? In question 15, listen. In question 15, mark the vector from A to B as vector AB. The arrow is given. The label is missing. Right? It should be vector AB. I didn't notice. Okay, we'll start. Eleven is a statement. Consider the following statements made regarding a particle describes a projectile. Right. First one, velocity is 0 at the maximum height. True or false? False. Why? Only the vertical component of velocity becomes 0. Right? Horizontal velocity component is never going to be 0. Right? That is tricky. Right? The given statement is tricky. Only the vertical component will be 0. Only the vertical one. You can't say velocity is 0. Velocity is not 0. That is why it is moving further beyond the maximum point. Otherwise, if velocity is 0, it should be stopped at the maximum point. Right? So the point is, A is wrong. 11. A is wrong. 11. A is wrong. The reason is only vertical component. Only vertical component is 0. Only vertical component is 0. Not the horizontal component. B. Total vertical displacement is 0. True or false? Correct or wrong? True. Right? Because it is coming back to the same level. No vertical displacement. So that is correct. C. It is subjected to a constant acceleration. Correct. That constant acceleration is gravitational acceleration. G. Right? Correct. B and C are correct. Correct statements. B and C. 11. Second one. Two. 12. So for B, what about it is being shot from a building? That's a special scenario, right? That's a special scenario. Right? When it says a projectile motion, by default we consider this, right? Otherwise, if there is something else, I mean, there is a special case, a special scenario, it should be given, it should be specified. Our by default case is this, right? That's why. 12. Two objects, x and y, separate by 5 meters each second when moving in opposite directions and approach by 1 meter each second when moving in same direction. Velocities x and y should be. Okay. The idea is like this. See, the easiest way is, now idea of a velocity 5 meters per second means it travels 5 meters per second, no? Right? So which means this object travels exactly 5 meters during 1 second. How can you make idea? Right? That's it. Underneath idea here, 5 meters per second means it travels 5 meters per each second. Right? With that idea, I'm going to argue this way. Two objects x and y separate by 5 meters each second when moving in opposite directions. Right? X and y. Right? When moving in opposite directions. Now, if their velocities are, right? Let's say velocities are also x and y. Right? If their velocities are x and y, now x meters per second means, right? Per 1 second, it travels x meters. Right? Then from here, it travels x meters to here. And from this point, y is going to travel y meters to the opposite direction. Then separation is going to be the addition of these two because they are traveling in opposite directions starting from here during the second. Then from this, what the idea that we can take is x plus y equals opposite directions from x plus y equals 5. X plus y equals 5. Right? Per second, all these arguments are per second. All these arguments are per second because velocity is something measured per second. So therefore, I have written all these arguments per second. And if they are moving towards the same direction, xn y. Say x and y. Now, during a second, this travels x meters, this travels y meters, right? Then the approach means they are getting close to each other by the difference. As an example, say we have two objects, right? One travels with 5 ms minus 1 and the other one travels with 4 ms minus 1. For each second, object A travels 5 meters, object B travels only 4 meters. Then the approach is, the distance, closing distance is only 1, right? Approach by 1 meter each second when moving in the same direction, right? Which means the idea here is, per second x minus y equals 1, right? Now we got two equations, 1 and 2, simultaneous equations at these two, 1 plus 2, right? Y cancels, 2x equals 6, x equals 3. If x equals 3, y equals 2, right? 3 and 2, 3 and 2, answer 4. There's a small thinking here. That's a thinking. That's a thinking part. There's a thinking. So for B, what about being? That's the answer. Right. A small thinking. Answer solved. Make it out. Luck. Other right. Tanisha? No. Linear motion. These are question from linear motion. Something from linear motion. Next, 13. Inertia of a system is measured by. This is something upcoming in rotational motion, right? Just know for the moment. When mass increases, inertia increases. When mass decreases, inertia decreases. So it depends on mass. So it is measured by mass, right? Mass. For 13, answer 5. Yeah. Huh? Inertia. Inertia again, that's a reluctance to move an object. Is called inertia. Reluctance to move. Right? In rotational motion, we discuss about inertia as there are two types of inertia. If there is an object at rest, it has a reluctance to move. If there is an object moving, it has a reluctance to stop. So either way, there is inertia. Simply, idea of inertia is there is a reluctance for an object to change its present state, the current state. That is called inertia, right? Very explain because that is coming up in rotational motion, right? Thank you. So after friction, we have rotational motion. No? 14. 14. An object starts its motion from rest and moves with uniform acceleration for time t1. Uniform acceleration. Uniform acceleration is a constant acceleration, right? Then only one answer. Then it moves with uniform velocity and for time t2. Finally, it returns to the final position under deceleration. The correct displacement time and acceleration time curves are. There's a typo in the acceleration time curve. Right? Correct. There's a small typo. We'll correct it. Give me 1 second. Then it moves with Returns to initial position under deceleration. It's there, it's there. Returns to initial position under deceleration. It's there. See? That's a good one. How done that? Look at here. An object starts its motion from rest. So let's say I'm just trying to understand the motion. Right? Somewhere here, this object starts a motion from rest, u equals 0. Right? U equals 0. And rest and moves with uniform acceleration for time t1. This is t equals 0. Try to understand the motion. And it travels with the uniform acceleration. Let's say a1 for some time until time equals t1. Right? Then it moves with uniform velocity for time t2. For a time t2. Then from here to here, let's say this velocity is v. Right? From here to here, it travels with uniform velocity. Velocity is same until this point t equals t2. Right? Finally, it returns to the initial position. Which means now it should come back. It should come back. So it is coming back. It is coming back. Something like this. It is coming back. Right? Under deceleration. Then for this returning motion, there is a deceleration, which means along this direction, this is a deceleration. Let's say A2. Right? This is equivalent to an acceleration in the opposite direction, isn't it? Deceleration in this direction is equivalent to acceleration in opposite direction. Which means, if you understood this point, the question is done. This direction and this direction is ultimately same. Right? And they are constant accelerations. So answer 5. For 14, answer 5. This is the point in the question. Na? It returns with the deceleration. If it was a deceleration to the same direction, what you said was correct. Right? It returns with the deceleration. Opposite direction deceleration, again, there is an acceleration to the initial direction. Is that clear? This is the point. That is the point. Right? Answer 5. That is also a tricky one. A tricky question. Take it down and ask if any questions. So you better sketch the motion and try to understand the motion. Otherwise, just by reading out a question, you won't get the exact picture of the question at once, right? So sketch it, especially when it comes to mechanics questions like linear motion, projectile motion, force equilibrium, right? Newton's laws, momentum, right? Sketch is playing a role, a major role there. 15. Okay. What's the answer you got for 15? 15 and another. Will you explain it again? You mean 14? 14. Are you asking about 14? Yes. Listen again. The object starts from rest and it says it accelerates to particular direction. We don't know whether it's to the right or left, right? Doesn't matter. Even if you consider to the left, then these two will be ultimately same. That's the point, no? Right? So initially it is accelerated and then moving to the same direction with a uniform velocity. And it returns. Returns means now it is coming back. It is coming back with a deceleration. Coming back motion. Now initially I considered a rightward motion. So the return motion should be a leftward motion. And for that leftward direction, this is a deceleration. For the leftward direction, this one is being a deceleration. For a leftward deceleration is equivalent to a rightward acceleration. Right? Vectors no. Leftward deceleration equals to a rightward acceleration. So which means A1 and A2, directions of A1 and A2 are same. right? If this is positive, this should also be positive, right? That's the only point. That's the only point. So in question in answer 5, two positive accelerations are given and they are constants, right? So at once you can pick, right? It's fine now, no? 15. No, that 15. 2 BC. Is that it? Online? What are the answers? For 15. 15, 15. So 15, 1, 1, 0. No, it is not 0. It is not 0. It's a non-zero value. So how does the ball return if it is accelerating? It returns with the deceleration. Returns with the deceleration. Right? Returns with the deceleration. Now, for this acceleration also we can say this is a deceleration to the leftward direction. No problem now. Right? Because deceleration is a negative acceleration. In terms of vectors, we know vector is negative if the direction is opposite. That's the meaning, no? That's the meaning. Therefore, always, this is what we proved in vectors. मैंने मेरे को use करे. Can you remember vector AB can be written as minus vector BA, no? Same thing. Exact same thing. मैं क्या use करे? Vector AB can be written as minus vector BA. Right? But how does the ball return to original position if it is moving forward? It is moving towards this direction. The actual motion is leftwards. So it is moving to this direction. Right? Don't get confused. Right? It is returning. Returning with the deceleration. Returning with the deceleration means along the way it decreases velocity when it is returning. Right? So at some time it will reach the initial point. Right? At some point, at some time, after some time, it will reach the initial point. Right? Clear? Okay. 15. A regular hexagon. Vector diagrams. Right? Vector diagrams. We discussed. Vector diagrams. A, B, C, D, E, F. Vector diagrams. Vector AB. Vector BC. Vector CD. Vector DE. Vector FE. Vector FA. That's all. Right? So when it comes to vector diagrams, when we simplify vector diagrams, mainly there are two theories we use. Right? What are those? Vector parallelogram. For diagrams specifically, for vectors there are 3 laws. For diagrams, either vector triangular law or vector additive law. Right? So most commonly what we use is vector triangular law and vector additive law. For vector diagrams, vector parallelogram is also a vector law, right? But that is only for 2 vectors. So therefore, it will be used in any other cases. If we don't have a visible triangle or other polygon, right? දෙකක් තිබ්බොත් මේක use කරන්න පුළුවන් parallelogram එක. නැත්නම් diagrams වලට specifically යන main laws දෙක අර දෙක. Triangle and the additive law. Because additive law is valid for any number of vectors. No? From these two, the fastest one is the additive law. Using additive law is faster because it simplifies more vectors at once. Vector triangular law is also only for 2 vectors. Right? Okay, so you can start from anywhere that you prefer. You can start from any point, anywhere that you prefer. Right? See, start from here. Now at once what I notice is these arrows are inline now. Since arrows are inline, at once we can use additive law. Take a lazy because additive law is valid for any number of vectors if coefficients are equal. If coefficients are equal, use additive law at once, right? To you to understand the steps, I'll be writing the steps. Otherwise, if you can do this simplification just by the mind, that is totally fine because this is MCQ, right? This is MCQ, no, right? If you can simplify this just by the mind, totally fine, totally fine. See, these to you to understand the steps. Vector FA plus vector AB plus vector BC plus vector CD plus vector DE, right? After E we can't simplify because arrow is opposite. Arrow is opposite, right? Arrow is opposite. Now, if you have written this properly, I have told you these things. The ending letter of the first vector should be the starting letter of the next vector. Okay? That pattern is there. A, B, B, C, C, D, D, right? So final vector means resultant is always the vector between initial and final points. Initial point is F, final point is E. So this gives a vector Fe as a resultant. This gives vector Fe as a resultant. There was a Fe already here. There is a Fe already here, right? And this is the simplified Fe. Then we can simplify Fe with Fe. We can simplify Fe with Fe. It gives 2Fe. It gives 2Fe. 2Fe. But 2Fe is not given. 2Fe is not given, right? If direction and magnitude of a vector is same, vector should be same, no? Because for a vector, there are only two parameters, direction and magnitude. If both direction and magnitude are same, which means both of them are same vector. Now, if you just consider vector BC and vector Fe, since there is a regular hexagon, these two sides are equal, isn't it? These two sides are equal, not just these two, all these sides are equal, no? Regular polygon, regular hexagon, right? Now, size is equal means magnitude is equal. What about the direction? See, same direction. Same direction. This makes an angle of 30 with this, right? 30, 60. 60 with this. And this is also 60. Internal angle of a hexagon is 120. Right? Done on it? Same. So direction and magnitude both are same, which means we can say this. You can say vector Fe is equal to vector BC. Because both direction and magnitude are same. Therefore, vector 2Fe can also be written as vector 2BC. Right? This is a small out of the box thinking here. That make a simplified make a value. This is not given in the answers. Right? This is not given in the answer. Sometimes you might have got this. And you might be confusing why 2Fe is not given. Because this another extra mile is here. Extra mile is gone. Right? 2Fe can be written as 2BC. So answer is 2. For 15, answer 2. If both direction and magnitude of a vector is same, right? Which means both vectors are equal. Both vectors are equal. Is it clear? Are 2BC આવને 2BC જતા મેં કહું તો દાદા 2Fe આવે ને 2Fe આવે આ કહેતા કે 2Fe is not given. 2Fe આવે 2Fe is not given. මෙන්න මේක තමයි ඒකේ තියෙන පොඩි thinking part එක. This is the thinking part given in the question. This is the thinking part. A creative thinking part given in the question. Vector Fe equals vector BC because both direction and magnitude are same. Right? So instead of writing Fe, we can write BC instead of Fe. They are same. Right? Okay. That's all. Right. Next 10, sorry, next five questions. 16 to 20. 8, 42, Right. 16 to 20. Start 16 to 20. 842. 842 to 852. Start. Process. നീട്ടത്ത് എത്തണം. Okay. Right. 16. 16. Percentage errors in three quantities A, B, C are 1%, 1.5%, and 2% respectively. Quantity A is given as A equals AB squared C. Percentage error in A is. Right. So this is the theory regarding percentage errors in equations. See, say we have an equation as say y is, no, let's say k. We have an equation as k, a to the power x, b to the power y over c to the power c, something like this, right? This is how percentage errors are evaluated, right? In an equation, always whatever the index of the term comes as a coefficient, right? What pattern as a pattern. So if you need error percentage in k, right? Percentage error in k, it is written as this is x no x times percentage error of a, right? Because the idea is like this. Say that is L squared. Now, if you made an error when measuring L in an equation where L squared is considered, you are doing the same error. You are doing the same error in the calculation 2 times, because this L squared means L times L, no? 2 times you are doing the same error. So therefore, this 2 is taken to the front. That's the concept behind this, right? If you are say using a cube in the equation of a particular measurement that you have taken, if you are using a cube, which means that same error repeats 3 times. Same error repeats 3 times. Therefore, it is 3 times of an error. That's the idea. That's the idea. What's the point? Therefore, plus y times error in B, percentage error in B, and about C, we can write this same thing as AX, BY, and if you take this to the top, C times minus 0, right? Indices. Okay, that one. 1 over x is x to the power minus 1. 1 over x is x to the power minus 1. So this is C times C to the power minus C. So this is minus C times error of C. Right? So that is how these errors are going to behave. That is how the errors are going to behave. Right? So if you don't know this, this is the theory. Right? Write this down as the theory. Take this down as the theory. ඒක දන්නවා නම් ඔගේ ආන්සර් එක නිකම්ම ගන්න පුළුවන්. Right. Now, the given question. A equals, capital A equals A, B squared C. A, B squared C. Right? Percentage error in A is, percentage error in A can be written as A. Coefficient of, the power of A is 1, no? That is 1. Which means, error made when measuring A is 1. Right? 1 times percentage error of A plus 2 times percentage error of B plus 1 times percentage error of C. Right? Because nothing given here means 1 is here. Nothing given means 1 is here. Right? Percentage error of A is 1%. Plus 2 times percentage error of B is 1.5%. Plus percentage error of C is 2%. Right? 1 times 2%. 2 times 1.5 is 3, 4, 6. 6%. 16, answer 5. Right? 17, equilibrium. 17 is force equilibrium. 17 is from force equilibrium. 17. A buoy of mass 60 kilograms is in equilibrium by pulling down a cable passing over two smooth pulleys. If he is lifted off the floor, the force applied by the buoy on the cable is right. Okay, first tell me how many strings are here? Strings, or we can say cables. How many cables are here? How many cables in the given system? How many cables in the given system? First question. How many cables in the given system? Online? How many cables in the given system? One. Online? How many cables? How many cables? Quickly. How many cables in the given system? You mean with something here? It's directly the hand, right? It's a hand. Yeah, there is only one. There is only one. Right? Only one cable, and he is grabbing this point from one hand and this point from the other hand. Right? Otherwise, if there's a string here or a cable here, it comes to two, right? But according to the diagram, it seems it is directly grabbing by the hand. Then only one string, one cable, right? If there is one cable, same tension remains, same tension acts throughout the cable, right? So let's say this is T. This is the same cable. This goes over this larger pulley, goes over the smooth pulley, and connected to here. Same string. Starting from here, goes over the larger pulley and the smooth pulley, connected to here. T, same string. So this is also T. This is also T. Goes around. This is also T. And this is also T. This is how tension should be marked. Right? This is how tension should be marked. 60 kilograms. Okay. Then weight of this buoy is 600 newtons. Right? Tell me, is there any reaction between the hand here and the pulley? Hand of buoy with the pulley. Is there a reaction? Yes, there's a reaction. At this point, right hand, there's a reaction. Are they mutual reactions? Are they mutual reactions? Are they mutual reactions? Yes, they are. Yes, they are. Because if there is a reaction on hand by the cable, there should be the mutual reaction on the cable by hand. They are mutual. Right? At each point, they are mutual. But I don't need that in the calculation. Therefore, I'm going to consider this system consists of the moving pulley and buoy, both of them at once. Because if I'm trying to consider only buoy, what happens is reactions at these two hands are coming. I don't need to include something that is not relevant for the question in my calculation, right? So therefore, the trick is we can use both of them to cancel their internal reactions, right? Right? The force applied by the buoy on the cable is okay. Then anyway, we have to consider the buoy as well. We have to go to two steps. Right? I thought the tension. Right? If there is tension is coming at once, right? The force applied by the buoy on the cable. By the buoy on the cable. That is about one part. See, now if I consider the vertical equilibrium of this system, VE, vertical equilibrium, vertical upwards, force equals vertical downwards. Vertical upwards we have 3T. Vertical downwards only 600. Right? So T equals 200 newtons. T is here. Tension of the cable is 200. Now the question is about the force applied by the buoy on the cable is force applied by the buoy on the cable. It is visible here. See, it is visible here. Buoy is applying the direct force here on the cable at this point. On the cable, this force is applied on the pulley. On the pulley. So on the cable is here. That is exactly equivalent to T. They are mutual, no? Equivalent. They are mutual. They are mutual. Because this T is the tension on cable by hand. The mutual reaction is on hand by cable. So therefore, force applied by the boy is also 200. Same. That's it. 17. Answer 4. An equilibrium question. An equilibrium. Equilibrium of forces. Equilibrium of forces. Take it down. $18. The figure shows 4 vectors. What should be the direction of the fifth vector such that the resultant is 0? Right. 4 vectors are given. 4 vectors are given. 4 vectors are given. 3 newtons, 5 newtons, 4 newtons, and 4 newtons. Right? Listen. Listen. When simplifying vector diagrams means not the polygons, not vector polygons, vector diagrams like this. Vector polygons, the question 15 is a vector polygon. Right? 15 is a polygon. Make a diagram now. A vector diagram. If you are given vectors in multiple directions, right? Easiest way is you can first narrow it down to 2 perpendicular directions. Right? If vectors in multiple directions are given, first narrow it down to 2 perpendicular directions. Because we are more liking towards the perpendicular directions because resultant of a perpendicular vector can be written at once, no? Right? 2 perpendicular vectors. If they are x and y, resultant is root x squared plus y squared. Right? Therefore, we tend more towards perpendicular vectors. Perpendicular vectors දෙකක් දන්නවා නම් resultant එක කොහොමද දන්නව? So therefore, if omnidirectional or multidirectional vectors are given, first simplify it up to or narrow the system down to 2 perpendicular directions. Right? That's the most common approach. Right? Common approach. 4 MA, maybe 6, 5, 8, 10, any number of vectors are given. First, we are narrowing it down to 2 perpendicular directions. Right? So that's a favor. Okay. See, now I'm going to focus on vertical direction. Vertical upwards 5 newtons, vertical downwards 4 newtons. Then resultant of these two vertical vectors are 1 newton upwards. Right? 4 and 5, no? 4 and 5. So the resultant is 1 upwards. Alright? Vertically upwards 5 newtons, vertically downwards 4 newtons. 5 minus 4. So the resultant is, this is equivalent to upwards 1 newton. Right? About these two, 4 leftwards, 3 rightwards, resultant remains 1 leftwards. 1 leftwards. That's done. That's done. Resultant of 1 and 1 is equal, no? Equal means resultant is exactly in between, because we know for any 2 perpendicular vectors, resultant is always in between. If they are identical, resultant is exactly in between, 45 degrees. Right? So therefore, this resultant is exactly 45 degrees from this, because 1 and 1 are identical forces. Exactly 45 degrees from this. Right? So the correct direction is OB. Right? Correct direction is OB. 3. For 18, answer 3. Narrow it down to two perpendicular directions. That's the idea. Right? Take it down, narrow it down to two perpendicular directions. Narrow it down to two perpendicular directions. Nineteen. The micrometer screw gauge has pitch 0.5 millimeters and 50 divisions on the circular scale. The readings on the scales when measuring the diameter of a cable are shown. When measuring diameter of a cable are shown. The percentage error in the diameter measurement is. Okay. Then first you have to get the reading. Right? So we know always reading of any instrument which uses a vernier principle is the reading of main scale plus reading of vernier scale. Right? Reading completed main scale, micrometer screw gauge, I explained before. Gap between two divisions at opposite sides is 0.5. So this is only one opposite division is visible, which means completed main scale is 0.5 millimeters plus vernier scale is coincided divisions into least count. Coincided divisions, exactly 30. Right? Exactly 30 into least count 0.01 millimeters. Fine. So R equals 0.5 millimeters plus 0.03. Sorry, 0.3. 0.3. 0.3 millimeters. 0.30. 0.3 millimeters. Which means the reading here is 0.8 millimeters. Right? Percentage error is asked. What's the equation of percentage error? Percentage error is least count over reading times 100%. Percentage error. Right? Least count 0.01 millimeters. Reading 0.8 millimeters into 100%. Right? 0.01 into 100 is 1. Pardon? 1 over 0.8. 1 over 0.8 can 1.25. 1 over 4 is 2.5, no? Then 1 over 8 is 1.25. One point two five. 4. For 19 answer 4. That is an easy one. That is an easy one. A combination of measuring instruments and percentage errors. Can I know which year is this? What do you mean? I mean, about the paper? Oh, you're asking about the class? 20. The force effects on a body of mass 2 kg moving on a horizontal plane with initial velocity 10 ms minus 1. The variation of force with time is given. Velocity after 8 seconds is. Right. A FT graph. See, these are respective theory part. A FT graph. If you need to find what is represented by the area of a graph, right, what we should do is multiply the axis, right? So area is multiplying the axis f times t, right? We have explained this one under linear motion graphs, right? Not about ft, but about the area. If you need to find the physical quantity represented by the area, multiply axis. Now here there is f into t. What is f into t? The popular quantity. ft is ft. ft is impulse. ft is impulse. Right? So therefore, the idea here is area of this graph, ft graph, represents either impulse or we can write the same as delta mv. This is the theory. Right? Area of a ft graph gives delta mv. Area of a ft graph gives delta mv. Right. Momentum change again. Area of ft is momentum change. Now I'm going to get the area of this given graph up to 8 seconds, because we are asked about the velocity after 8 seconds. Right? Get the area up to 8 seconds. Area under the curve up to 8 seconds represents momentum change up to 8 seconds. Correct? That's a trapezium. That's a trapezium. 5 to 8 means 3. Area of the trapezium 3 plus 8 over 2 into perpendicular height 10 equals momentum change delta mv, right? mv minus mu. Then mass is given 2 kg, right? Final velocity is v. Initial velocity is given 10. I have to simplify this, right? This is 2 times 5, 11 over 2. Decimals here, 11 over 2 into 5 equals v minus 10. 55 over 2. 55 over 2 is 27.2. Yeah, it's 55 over 2 is 27.5 equals v minus 10. So v equals 37.5. V equals 37.5. For 20, answer 3. For 20, answer 3. Right. Start last 5 questions. 9, 14 to 9, 24. Start last 5. In question 25, a data is missing. Make this correction. For question 25, a monkey of mass 20 kg is climbing a ladder connected to a parachute of mass 40 kg. Connected to a parachute of mass 40 kg. Connected to a parachute of mass 40 kg. Okay. Sorry. Okay. Right. Okay. 21. Two objects A and B of masses 3 kg and 2 kg are connected by a heavy rope of mass 1 kg. Varied strings. Right? Varied strings. A force of 12 newtons is applied on on a smooth horizontal plane. The tension at the middle point of the rope is. To find tension at any point, first of all, you need acceleration. Apply F equals ma for the system. Right? Only force acts on the system is 12. Right? Total mass is 2 plus 1 plus 3 A. 12 equals 6A. A equals 2. Acceleration of the system is 2 ms minus 2. Right? So if you need to find tension at a middle point, break the system from that point. Right? And you have to break it from the point. And always tension forces remain as attraction forces. Right? Tension forces at the breaking point remains as attraction forces. Right? Easiest force frame to consider is this one. I'll be considering this. For this force frame, rightwards, F equals ma. Only force remains on that force frame is T. Mass of that part is 2 plus half of the string 0.5. Acceleration 2. T equals this 2.5, 5 newtons. 5 newtons. 21, answer 2. We discussed this. We discussed heavy strings. Heavy strings means weighted strings. We discussed heavy strings, weighted strings in the class. Right? Similar type of a question. Similar type. Weighted strings. Weighted strings. 22. A child of mass m standing on a weighing machine placed in an ascending elevator. Ascending elevator. Okay. The elevator is like this now. The child is on the machine. On the machine. The elevator is ascending. Right? The elevator starts its motion from rest and then accelerates upwards at a constant acceleration. Okay, after that it travels, right, correct variation of reading of the machine is. Listen, first what you should know about the reading of the machine is, reading of the machine is the reaction on the machine, right? Weighing machine, no, simply weighing machine is a balance, right? Weighing machine means a balance, right? So we call this kind of a balance as a pan balance. We call it a pan balance. PAN, pan balance. Reading of the pan balance is reaction on pan, right? Pan balance. මේ වගේ balances තියෙනවනේ. Haven't you seen? මෙතන උඩින් මොනවා හරි දීලා measure කරන්න. Right? Reading of this balance is reaction on pan, like this, right? So exact reaction on pan is equal and opposite on this child, say R, and on the child mgx. Now first phase of the motion, upward acceleration. No? I'm going to use F equals ma upwards, right? Upward acceleration. Then let's say first reading is R1 minus mg equals ma1. Let's say first acceleration is a1. It is given as a1, right? Now R1 is ma1 plus mg, right? Keep this for a moment, and then after that it travels at a steady speed, right? Second phase is at steady speed. If there is steady speed, acceleration is 0. Acceleration is 0. So therefore, if you use F equals ma, since acceleration is 0, if there is R2 equals mg. No acceleration. If there is no acceleration, forces are counterbalanced. Right? Third one. And finally, decelerates with acceleration A2. Yeah, A2 is greater than A1. Okay. This is a given data about A2. A2 is greater than A1. It decelerates with A2. Then again, for the upward direction, we can use F equals ma. Say final reading is R3 minus mg equals m. This is A2, but there is a deceleration in upward direction, no? Minus A2. It should be minus A2, right? Then subject R3 equals mg minus ma2. These are the answers for these three sections, these three scenarios, right? So first answer is the highest among all, ma1 plus mg, no? Or else mg plus ma1. This is just mg, this is mg minus something, right? And they are constants, because if acceleration is constant, this whole term is a constant. M is a constant, a1 is a constant, given mg are constants. So they are constants. Therefore, first of all, remove variable answers. 1 is a variable. First part is varying, no? 1 is wrong. 4 is wrong, right? 5 is also wrong, because we know values are different from section to section, right? Now the tie is between 2 and 3. First is highest. 2 and 3. Everything is there. And from this, you have to build up an argument again. A2 is greater, no? Since A2 is greater, this ma2, this term ma2 is greater compared to ma1, right? Since A2 is greater, ma2 is greater, which means the higher part is going to be deducted. Which means a small amount is going to be retained. Right? Which means R3 is comparatively less compared to this increase. mg plus ma1, but this deducted value is greater than ma1. A small value remains. Answer 2. For 22, answer 2. In third one, the equal heights are given. Equal heights are coming if it was same. If the ma1 plus mg, and if it was mg plus ma1, mg minus ma1, something like that. If the gaps are same, if the differences are same, only same heights are coming. Now differences are different because A2 is greater than A1, right? So as a value, ma2 is greater. ma2 is a greater value as a value, right? From mg, the higher value is deducted, right? 2, answer 2. That question is from Newton's laws. That is from Newton's laws. That is from Newton's laws. 23. 23. A car accelerates from rest at a constant rate alpha for some time. Okay, let's say it starts here, right? And it accelerates with alpha for some time. We don't know the time, so let's say this time is t1, right? And after which it decelerates at a constant rate beta to come to rest. Okay, now here it has gained some velocity, let's say v, and initially it is starting from rest. It is given. Initially starting from rest, right? That is given. And after this point, it decelerates. After this point, it decelerates. After this point, it decelerates. And finally, becoming rest. Decelerates and come to rest. And deceleration is beta. Towards this direction, minus beta. That's a deceleration, right? Okay, and let's say this time here is t2. And there's another data given as if the total time elapsed is t, then the maximum velocity at end is. Okay, total time is t. No? If total time is t, we can say simple t equals t1 plus t2, isn't it? Total time is t, right? And maximum speed is asked, maximum velocity. Now tell me at which point of the motion maximum velocity is attained. At which point of the motion maximum velocity is attained? Exactly at this point. Because up to this point it is accelerated, and just after that point it decelerates. Then velocity decreases also. So maximum velocity is here. Maximum velocity is here. Now my target is finding this v, right? Okay. Now since times and velocities are known, we can apply linear motion equations considering these two sections. See, v equals u plus ad for the first section, right? First section, na? First. V is V, U is 0, A is alpha, T1. If T1 is subjected, I can plug here. That's my target. I'm going to subject T1. V is alpha T1. Then T1 is V over alpha. T1 is known. Similarly, now my idea is to find T2. Apply V equals U plus AD again for the second time interval. Right? V equals U plus AD again. V is V dash is 0. Right? U is V because second section is from here to here. Initial velocity of that section is V. Right? Minus beta T2. Correct? Beta T2 equals V. T2 equals V over beta. Right? Plug these two here. Say this is equation 2. Plug these two here, which means T equals T1 V over alpha plus T2 V over beta. Right? We need V. Then apply a common denominator. It is alpha beta. Right? Common denominator is alpha beta. Then this is beta times V plus this is alpha times V. Right? Cross multiply this. That is alpha beta T. Take V out, alpha plus beta. We need V. V is alpha beta T over alpha plus beta. Another good question from linear motion. Alpha beta T over alpha beta T alpha beta 1. Eh? For 23, answer 1. Another good question from linear motion. Right? Stevie. Right. Take down. Another good idea, good concept from linear motion. See how this given data is managed. Right? That's the thinking of the question. That's the thinking. Right? So what you need to understand is the thinking of the question. Correct color, get the concept, the thinking behind the question. 24. 3 objects ABC of masses 4 kg, 4 kg, 2 kg and 1 kg. 4 kg, 2 kg and 1 kg are placed in contact with each other. A 3 Newton force is applied on A. Then this given force is 3 Newtons. The force generated on B by C is on B by C. A, B, C. On B by C, no? On B by C is this. Right? Equal and opposite reaction of this one is on C, like this. Right? Internal reactions. Right? We discussed under separate heading as determination of internal reactions of objects. Right? We discussed under separate heading determination of internal reactions. Reaction between these two is like this. To find the reaction, first of all, we need acceleration again. Right? So apply F equals ma for the system. Apply F equals ma for the system. F equals ma for the system. Only F remains unbalanced in the system is 3. Right? All internal reactions get cancelled each other. M is 4 plus 2 plus 1 into A. Make answer tibbada. Tibbane. I think this force is 30. Make 30 the answer. I didn't notice that typo. Make 30 the answer. One second. There's a typo. 1 second. 4, 2, and 1. Right? Let's correct this way. This applied force is, right? This is a typo. This applied force should be 28 newtons. Correct this as applied force is not 3, it should be 28. But 28 Newton force is applied on A. Make that correction. But 28 Newton's force is applied on A. But 28 Newton's force is applied on A. No answer. Yeah, that's why. That's a typo. Right? That is not 3 Newtons. It should be 28. Okay. Now this is 28. See? 28. 28 equals, this is 7, no? 7A, A equals 4ms minus 2. Right? And easiest way to find this C is considering the force frame of C. To find this force, apply F equals ma considering the force frame of C. Only F is R, mass is 1 into acceleration 4 newtons. 424, 4. Right? With this correction, no? With the correction of 28. With the correction of 28. 25. Last question for the day. Last question for the day. A monkey of mass 20 kg is climbing a ladder connected to a parachute. Parachute of mass 40 kilograms. Find the descending velocity of the parachute with respect to Earth when the monkey climbs at 4 meters per second steadily with respect to the ladder. Okay. A relative motion is given. This is the principle of relative velocities. If you need velocity of A with respect to B, it can be written as velocity of A with respect to Earth plus velocity of Earth with respect to B. This is called the principle of relative velocities. Right? Principle of relative velocities. If there is a third party, we can make that third party the intermediary party. This is what is happening. VAB, no? Now, Earth is being the third party. Then VAE plus VEB. That's a pattern. It is like this third party is coming in between. VAE plus VEB. Velocity of A with respect to B. This is velocity of A with respect to Earth. Velocity of Earth with respect to B. Right? Okay, now let's apply this to this given scenario. The parachute is given with this one. With this one. And it says monkey climbs 4 with respect to parachute. 4 with respect to parachute, no? So let's label this way. Let's say parachute is P, monkey is M. Right? Now this given velocity is velocity of monkey with respect to parachute. Right? Velocity of monkey with respect to parachute. By default, our velocities are considered with respect to what? By default, with respect to Earth. Right? By default, all velocities are considered with respect to Earth. Right? So therefore, specifically we don't mention it as with respect to Earth because there is a default scenario. But if it is given with respect to any other different physical quantity, any other different, not the quantity, any other different force frame, right, or an object, that we have to mention specifically like this. So therefore, velocity of monkey with respect to parachute is 4 upwards. That is what is given. Right? And let's assume velocity of parachute with respect to Earth as VPE. Right? And velocity of monkey with respect to Earth upwards as velocity of monkey with respect to Earth, no? VME. Right? Upwards, say U, up U kilogam. And let's say this one is V. Now my final target is finding V. Okay. Linear momentum is applicable only with respect to Earth. Linear momentum is applicable only with respect to Earth. So that's the point I am going to start. Linear momentum is applicable with respect to Earth. Right? So see what is happening. Now if we use linear momentum, for the system using conservation of linear momentum, right? Conservation of linear momentum. Now, before monkey starts a motion, system should be at rest now. Now, when monkey starts a motion, both of them are moving. So let's say we are using the equation in this way, right? Then mass of monkey is 20 and velocity of monkey with respect to Earth is upwards u, and mass of the balloon is parachute is 40 and direction of velocity with respect to ground is v downwards, so that is minus v using upwards, right? Simplify this, minus becomes positive here, 40v equals 20u, right? These two cancels, u equals 2v. We have got one important data as u equals 2v, right? Now I'm trying to apply relative velocities. Since velocity of monkey with respect to parachute is known, again I'm going to make Earth the intermediary, right? Velocity of monkey with respect to parachute can be written as make Earth the intermediary party, right? Then velocity of monkey with respect to Earth plus velocity of Earth with respect to parachute, right? Earth is coming in between. That's a pattern. VMP is upwards 4, right? And VME is U, right? Upwards U equals 2V, no? So which means we can mention this as upwards U equals 2V. 2V because my final target is finding V. No need to keep U in the calculation. VEP, if VP is downwards V, VEP should be upwards V, right? Vectors, no? Vectors. I'll make an answer. Come on, we'll correct an answer. Plus VEP should be upwards V. Right? So which means 4 equals 3V. V equals 4 over 3 ms minus 1. This is actually 1.33. 4 over 3 is 1.33 ms minus 1. 1.5 is given. 1.5 is given. So we'll consider 1.5 as the final answer. May round up answer answer 2. 1.33 is coming. So we'll consider the final answer as 1.5. Right? That's a combination of relative motion with linear momentum. A combination of relative motion with linear momentum. Relative motion with linear momentum. Relative motion with linear momentum. Write down. Right. So with that, we have come to the end of the discussion of 25 MCQs. Any questions from the questions we discussed today? Maybe. Online? Any questions about the 25 MCQs we discussed today? I mean, before winding up, clarify if there's anything. Clarify if anything before winding up. Okay. Others? Okay. Right. So listen while writing. Next week, you will be writing part 2 of this same paper, right? It will consist of 2 structured essays and 2 essays, right? So get ready to write 2 structured essays, especially go through measuring instruments, right? Especially go through measuring instruments and VT graphs, VT, ST, AT, everything, linear motion graphs, right? Vector parallelogram theory, right? Those things. And for the essay parts also, linear motion, linear momentum, projectile motion, right? Those are the significant parts, right? So get ready to write a second paper next week. Right? All right. So if no any questions, we'll wind up. Have you finished taking down? Right. So 1.33 comes. We can consider 1.5 as the rounded answer. Finished. Right. So for the first month, you will be practicing questions like this in the class, and then you will be writing papers separately, and I'll be giving you the graded papers, right, with ranks, right? The rank එක මම කියනවා class එකේ rank එක කියනවා කියන ඔක්කොම ranks නෙමෙයි, like first 5 something like that, first 5 ranks වගේ class එකේ කියනවා, right? First 5 or first 10 we'll see. Everything I mean to make you motivated. දැම්ම නෙමෙයි, දැන් next week අහන්න එපා rank එක මොකක්ද කියලා. දැන් තකවා next week අහනවා සර්වගේ rank එක මොකක්ද. Right? That is next month onwards, ranking and everything. Right? No questions, no? If no questions, we'll wind up. Get ready for a second paper to write next week. Right? Okay. And stay connected and keep in touch in the group. Right? If the time is shifted to 7, I'll be informing it through the group. Right? All right. If that is not shifted, it will be at 6:30 as today. If shifted, it will be at 7. Right? I'll be informing before the next week through the group. All right then. If no any questions, we'll wind up. We wind up. Stay safe and go safe and work hard. Right? All right then. Good night and goodbye.